Let's look at another exam question. We must not forget that we must first eliminate the theorems which are not on a problem. Then we are going to be left with the theorems which are in the problem. We are going to solve that theorem with what we have learned in part 1. Now, here is another example here. It looks complicated, but if we can eliminate all the theorems which are not on this problem, then it will be easy to solve whatever that needs to be solved. Now, in the sketch, dA and dB are tangents to the circle at A and B. Therefore, dA and dB are tangents to a circle at A and B. Now, AF is equals to FB, AF is equals to FB. We need to show that they are equal. This is equals to this side. Now, we are also told that AB produced, so it is produced to C. We are also told that AB produced, cut the line through D. It cuts AB produced, it cuts the line through D. It cuts the line through D, which this line is parallel to this line. As you can see that this line is parallel to this line. Therefore, that's what they say. AB produced, cut the line through D, parallel to FB at C. So it is produced at C. Now, AF is produced as well. You can see AF produced, meet BC at E. AF produced, meet DC at E. Now, we are also told that D angle AE, D angle AE, this angle there is equals to X. Now, 8.1, they say find with reasons 5 angles equals to X. Find with reasons 5 other angles which are equals to X. Now, the first thing that we must do, we must eliminate all the theorems which are not in this problem. And let us eliminate them. We first ask ourselves, are there chords? Yes, there are chords. Are there cyclic quads? They didn't talk about cyclic quads here. They didn't talk about cyclic quads here. Therefore, there are no cyclic quads. Are there tangents? They did tell us about tangents. Therefore, we do have tangents. Now, let's eliminate these theorems one by one. We know that we've got 4 theorems on chords. Now, we first see that we ask ourselves, is there a line from the center? There's no center. So is there a line from the center to the midpoint of the chord? No line from the center to the midpoint of the chord, or no line which is perpendicular to the chord. Therefore, theorem number 1 is out. Is there angle at the center? There's no center. So there's no angle at the center, which is 2 times angle at the circumference. Therefore, theorem number 2 out. Theorem number 3, is there diameter? They've never told us about a diameter here. Therefore, there's no diameter. Theorem number 3 is out. Is there angles at the same segment here? We can't say this and that are angles at the same segment yet, because at this point we are not, these are not in a circle. You can see that. Therefore, there's no theorem number 4 as well. Therefore, theorem number 1, 2, 3, and 4 are out in this problem. Now, cyclic quads, already they are out because they never told us about cyclic quad. Even though they are going to ask us to prove that something is a cyclic quad, but it does not mean that we are given that we've got cyclic quads. Therefore, we don't have cyclic quads because they never talked about any cyclic quad here. Now, tangents. Yes, there are theorems on tangents. Is there a radius and a diameter perpendicular to the tangent? No, there's no radius, there's no diameter which is perpendicular to the tangent. Theorem number 7 is out. Theorem number 8, are there tangents from the same point? Yes, because they said DA and DB are tangents at A and B. And you can see that they are from the same point. Therefore, theorem number 8 is there. Is there theorem number 9, which is, yes, there is theorem number 9, because we do have a chord making an angle with the tangent, which is going to be equals to an angle which is at an alternate segment. Therefore, you can see this chord, it makes an angle with the tangent. Therefore, this obviously is going to be equals to that, as I can see. Okay, therefore, it means that we do have theorem number 9. Therefore, in this problem, we only have theorem number 8 and theorem number 9, which we are going to use to solve this problem together with what we have learned in part 1. Now, we are told to find 5 other angles which are equals to x. Well, look. Now, 8.1 tells us that we should find, with reasons, 5 angles equals to x. We must find 5 angles equals to x. Now, what we know is that we've got theorem 8 and 9 in this problem. Now, we can find that this angle, B1, is equals to this angle, since this tangent makes an angle with this chord here, AF. This angle with, this tangent makes an angle with the chord AF. Therefore, this angle is equals to this angle, because this angle is subtended by this chord. Therefore, we start. We say that angle A1 is equals to angle B1, which is equals to x. Reason, tan, chord, theorem. Now this is the first angle equals to x. Another angle equals to x, obviously, since AF is equals to FB. We've got an isosceles triangle AFB. This triangle, it's an isosceles triangle. Therefore, it means that angle B1 is equals to angle A2. Therefore, angle B1 is equals to angle A2, which is also equals to x. Reason there, we know that triangle AFB is isos. And why is it an isos? It is because of AF is equals to FB. Now, we now have that this angle is equals to x as well. We know that this angle is x. We also know that this angle is x there. Therefore, there's a chord which makes an angle with the tangent, which is B2. This tangent makes an angle with the chord. Therefore, this angle is equals to that angle there. Oh, okay. So it means that angle A2 is equals to angle B2, which is equals to x, because this angle is equals to that angle there. Therefore, reason, it's still tan chord theorem, because we have a tangent making an angle with the chord, and this chord subtends this angle. Therefore, this angle is equal to that angle, Tanquart theorem. There's another x that we have there. Now, we can see that these two sides are parallel. We have used our theorem number 9 there and there. Here we've used isosceles triangle. Now, we can also use this part where we have learned in part 1, talking about Z shape or an N shape, where we have this angle there is equals to this angle there. There is your Z or your N shape. Your Z facing that way. This angle is equals to that angle. There is equals to there. Therefore, angle B2 is equals to angle D1, which is equals to x as well. Now, reason here, we have just said it, that interior alternate angles. And this is not an L. I want us to be clear on that. This is just an angle. It's just something that shows an angle. Therefore, this is not L, but it's an angle. Interior alternate angles. Why are they interior alternate angles? It is because DC is parallel to FB. Now we've got 4 angles which are equals to x, because also this angle there is equals to x. Now we want the 5th angle which is equals to x, and we can do this however we prefer, because I know that this triangle here, I'm going to show you an easy way of getting this angle. But someone who didn't see what I'm going to show you after can do that, where I have this angle there, plus this angle there, plus that angle there. We can find this angle C there. But now our problem is that this is the angle that we are still need to find. But obviously, here we are going to take a long drive to find this angle there. But let's find it anyway. Can I remove here? I remove. Now, we can find this angle to be x because I've got a lot of information there. I still need this angle there. I can find this angle there. And for me to find this angle there, I can use this triangle DADB. I can use this triangle ADB to find this angle there. Because I know that this is x and x. I know that this is x and x. Therefore, I can say angle A1 plus angle A2 plus angle B1. Angle B1, yes, plus angle B2, angle B1 plus B2 plus angle D2 is equals to 180 degrees. I've added this angle, which is angle A1 plus A2, plus this angle, which is angle B1 plus B2, this angle, plus angle D2, which is sum of angles on triangle ADB. Now, we know this, it's x plus B1 and B2 are also x plus angle D2, which is equals to 180 degrees. This is 4x plus angle D2, which is equals to 180. Angle D2 is equal to 180 degrees minus 4x. So this angle we know is 180 minus 4x. Now, we can find this angle because we know this angle it is x, we know this angle it is 180 minus 4x, then we can add this plus that plus that. Now, we can use triangle ADC to get this angle there. We use it, but this is a long try, as I've said. You will see how easy am I going to find this angle. Now, we have angle, we want that, so we're going to have angle D1 plus angle D2 plus angle A1 plus angle A2 plus angle C is equals to 180 degrees. Reason sum of angles on triangle ADC. Sorry, ADC. Now, we know that we're going to have D1 is x, D2 180 degrees minus 4x plus A1 is x, A2 is x plus angle C equals to 180 degrees. Now, we can see that we're going to have this is going to cancel with that because they've got the same sign there and there, and they are on both sides. Therefore, this cancels with that. Then we are going to be left with this, which is 3x. Therefore, negative 4x plus 3x is going to be negative x. Negative x plus angle C, which is equals to naught, because this cancels with that. This is going to be 3x minus 4x, which is minus x, plus angle C. Angle C is equals to x. If we wanted, I just took a long try, I can take another long try, of which I'm going to say this angle plus this angle, which is an exterior angle of a triangle, is equals to the sum of opposite interior angle. If we wanted, or we could have got this angle by using the exterior angle of a triangle is equals to the sum of the opposite interior angle. Therefore, this angle is equals to this angle plus this angle. Therefore, we do it. Angle B1 plus angle B2 is equals to angle D1 plus angle C. Why? Because this angle, which is this angle B1 plus B2, is equals to this angle plus this angle. Exterior angle of a triangle, which is that, is equals to the sum of the opposite interior angles. Therefore, we know B1x plus x, which is equals to, we know D1, it's x there, plus angle C. Now this is 2x is equals to, 2x is equals to x plus angle C. I take this x there, it's going to be 2x minus x equals to angle C. You can see that angle C is equals to x. I took a long try to get this angle to be x with the first method that I've used, or I can use this one where I use the exterior angle of a triangle is equals to the sum. We still get the same answer, which is x, C is equals to x. Even if I use the exterior angle equals to the sum, or even if I use this triangle to get there. But in an actual fact, it is very easy. If you couldn't see, if you've done that, you took a long try. If you've done that, you also took a long try. In actual fact, there's an F here. And this F, we know from part 1 that corresponding angles, and you can see this F looks something like this. Therefore, it means that this angle there is equals to that angle there. Therefore, you can see angle B1 is equals to angle C. Therefore, angle B1 is equals to angle C, which is equals to X. Reason, corresponding angles. Why are they corresponding? Because DC is parallel to FB. That's the reason. Now, we have found the 5 angles that are equals to X, which is this one, this one, this one, this one, and that one. Sorry, and that one there. So even here we've got X there. Now, we are told to prove that ABED, it's a cyclic quadrilateral. Prove that ABED is a cyclic quadrilateral for 2 marks. I think this one. So it means that we don't need to stress a lot. Since this angle, A2 is X, which is equals to this angle, D1, we know that the converse of theorem number 4, where if we've got equal angles on the same side of a line, then those points together with the points on the line are concyclic or cocyclic. Now, here we can see that A2 is equals to D1. Therefore, these angles, they are equal. They are subtended by ED, which is a line. They are subtended by line ED on the same side of this line. This means that ABED are concyclic. Let's write it. ABED are concyclic. Why are they concyclic? It is because line ED subtends equal angles on the same side of line ED. Therefore, angle D1 is equals to angle A2. Since this line subtends equal angles on the same side, then ABED are concyclic. Therefore, ABED is a cyclic quadrilateral. Now, we are told to prove that A angle BE, we are told to prove that A angle BE is equals to 3D angle AE. We are done with proving that this is a cyclic quadrilateral. Now, for us to prove that A angle BE, A angle BE, which is the whole of this angle, is equals to 3 times the whole of this angle, which is D angle AE. Therefore, this angle is equals to 3 times this angle. We have to prove that. And for us to prove that, we need to start, since ABED, it's a cyclic quad, it means that angle A1 is equals to angle B3. This angle is equals to this angle. Angles on the same segment. Angles on, this is not L, it's just an angles on the same segment. Angles on the same segment are equal because this angle is equals to that angle there. Since this is a cyclic quad, we've just proved it, that this is a cyclic quad. It means that there's another circle, that an imaginary circle, the last time we did explain this, that there's a circle, imaginary circle, is not that it is cyclic on this circle. It is cyclic on this imaginary circle. That is why it is cocyclic. That is why these points are concyclic. Now, it means that this angle is equals to that angle, angles at the same segment, on the major segment of this circle, imaginary circle. Now, therefore, this is equals to x. We must not forget that, because A1 is equals to x. Therefore, it is equals to x there. Therefore, this angle, A, angle B, E, is equals to angle B1 plus angle B2 plus angle B3, angle B1 plus angle B2 plus angle B3 is equals to A angle BE. Now, we know angle B1 is x plus x plus x, which this is 3x, which is A angle BE. Now, A angle BE is equals to 3 times D A angle E. What happened there? This is because x is equals to D angle AE. We know that x is equals to D angle AE is equals to x. D angle AE. This angle is equals to x. Where I see x, I put D angle AE. Proved. Last but not least, they say to us, we must prove that we must prove that AD is equals to BC. We know that we can start by, now we can use theorem number 8. We haven't been using theorem number 8 since, so it's now that we can use theorem number 8 in this problem. Therefore, AD is equals to BD. Reason? Tangents from the same point. Tangents from the same point. This is from there. Tangents from the same point obviously have equal lengths. Therefore, it means that this length is equals to that length. Now, BD is equals to BC. Why is that? It is because base angles of triangle DBC. Why are they base angles? Because angle D1 is equals to angle C, which is equals to x. Base angles of triangle BCD, D1 is equals to angle C. This angle is equals to that angle. That is why we say that this line is equals to that line.